Good morning, students. In the previous class, we see some problem involving exercise 1.3. Now we continue the problem. We already tell how to find the composition of two functions, that is f dot g and g dot f. Now we continue the same problem involving f dot g and g dot f. You see in exercise 1.3, 10th one, f comma g, both the functions from R to R, that means real to real, are defined by f of x value is modulus x plus x and g of x value is modulus x minus x. Then to find f dot g, that is the composition function of two, f and g dot f. Now to find these two values. You see in both the functions one modulus is equal. You know very well modulus value is always positive. But it is a negative number or positive number is possible in x. So first we write the concept. The value of modulus x in lower class or 10th standard level, modulus means always a positive. But this within a modulus, this x has a two value. It may be negative or positive. So the value of modulus x is minus x. When it is possible means when x is less than 0. And this modulus x value is x whenever the value of x is greater than or is equal to 0. Now you have a little bit confusion. How it is modulus x become minus x? I say one example. Suppose I put the value of x is equal to minus 5. You see the value of minus 5 is less than 0. So now we need modulus minus 5. According to our definition, how to find modulus x? Minus x. So minus of minus 5. Minus x is we put on minus. Here the value of x is minus 5. So minus of minus 5 is plus 5. Or suppose I replace the value of x is just 5. The value of x is 5 is more than 0. 0 more than 5. So the value of modulus 5 is directly 5. So it is a working rule to find the modulus of any value. So modulus x has a two value. The value is minus x when x is less than 0. The value of modulus x is x, just the value of x is greater than or is equal to 0. Now we find f dot g and g dot f in all the cases. When x is less than 0, when x is greater than 0. To find all the cases. So, but it is a value of modulus x. When x is less than 0. First we find when x is less than 0. F of x value. How to define f of x? Modulus x plus x. Now we say x is less than 0. When x is less than 0, modulus x value is minus x. So the value of modulus x is minus x. Already plus x is there. So f of x value is 0. So when x is less than 0, exactly the value of f of x is 0. In other case, when x is greater than or is equal to 0. So to find f of x in both the cases, when x is less than 0 and x is greater than or is equal to 0, f of x. Same. How to define f of x? Modulus x plus x. When x is greater than or is equal to 0, what is the value of modulus x? When x is greater than or is equal to 0, the value of modulus x is exactly x. So x plus x. So f of x value is 2x. Now we find the value of f of x in both the cases. When x is less than 0, f of x value is 0. When x is greater than or is equal to 0, f of x value is 2x. Okay. The same, next to find the value of g of x in both the cases. When x is less than 0. G of x. How to define g of x? The value of g of x is modulus x minus x. Now our rating is x is less than 0. When x is less than 0, modulus x value is minus x. So g of x value is minus x. Already one minus is there. Minus x minus x. So g of x value is minus 2x. That means when x is less than 0 exactly, the value of the function g of x is minus 2x. What is the other case? The value of x is greater than or is equal to 0. When x is greater than or is equal to 0, g of x. When x is greater than or is equal to 0, how to define modulus x? Just x. So x. But already minus x is there. So plus x minus x, both are cancelled. So g of x value is 0. First of all, we find the two functions f of x and g of x. Suppose the modulus is not involved, directly we find f dot g and g dot f. But in the problem, modulus is involved, so to find in all the cases. So when x is less than 0, f of x value is 0. When x is greater than or equal to 0, f of x value is 2x. When x is less than 0, g of x value is minus 2x. When x is greater than or equal to 0, g of x value is equal to 0. Now we find one by one. First we find the value of f dot g. To find f dot g, so put heading f dot g. But to find f dot g in both the cases, when x is less than 0 and x is greater than or equal to 0. When x is less than 0, first we find the value of f dot g in these cases. F dot g. How to write f dot g or how to find f dot g? First of all, we include the function variable. The function variable is x. Both f and g is a function of x. So we say f dot g is also f dot g of x. Next, how to write f dot g of x? F of, what is the first function? F of. Within a bracket, we write the second function. First function, within a bracket, we write the second function. Now we write f of, okay, f of. Now we see what is the value of g of x when x is less than 0. When x is less than 0, g of x value is minus 2x. So minus 2x. Now we find the value of f of minus 2x. Suppose we consider it is x. What is the value of f of x when x is less than 0? When x is less than 0, f of x value is defined as 0. So f of minus 2x value is 0. So f dot g value is 0 when x is less than 0. One case is over for f dot g. But one more case is also there. What is the other case? It's the reverse of that one. When x is less than 0 over. Next, when x is greater than or is equal to 0. Now to find f dot g in when x is greater than or is equal to 0. Same. We write f dot g. How to write f dot g? F dot g of x. Next step, we write f of g of x. F of. First we enter the value of g of x. First we enter the value of g of x. Now what is the value of g of x when x is greater than or is equal to 0? When x is greater than or is equal to 0, g of x value is defined as 0. So we enter the value 0. Next, when x is greater than or is equal to 0, what is the value of f of 0? When x is greater than or is equal to 0, when x is greater than or is equal to 0, f of x value is 2x. When x is greater than or equal to 0, this x is multiplied with 2x. So f of x is defined as 2x. So how to write f of 0? So we write f of 0 as 2 times of 0. So f dot g value is 0. So the first cases is over. In both the cases, f dot g and f dot g, when x is less than 0 and when x is greater than or equal to 0, f dot g value is 0. But to find the one more cases, so we find these two values. Next, to find g dot f also in both the cases. So I write here, I put a heading g dot f. So to find g dot f in both the cases, when x is less than 0 and also to find when x is greater than 0. So I write here, how to write g dot f? We write g dot f as g of f of x. What is the next case? we write it is g of f of x. G of, first we enter the value of f of x when x is less than 0. When x is less than 0, f of x is defined as 0. Next, what is the value of g of 0 when x is less than 0? When x is less than 0, how to define g of x? Minus 2x. That means the nature of the function g as the bracket 1 variable is a multiple with minus 2. Okay, minus 2. So minus 2. Here x is there, so we write x. In place of x here, 0. So minus 2 into 0. So g dot f is also 0. Okay, now we find the value of g dot f when x is less than 0. What is the other case? When x is greater than or equal to 0. So to find g dot f in same, how to write g dot f of x? Next step, g of f of x. Yes, what is the next step? To find the value of f of x when x is greater than or is equal to 0. When x is greater than or is equal to 0, when x is greater than or equal to 0, f of x is defined as 2x. 2x. Now we write the value of g of 2x when x is greater than or equal to 0. When x is greater than or equal to 0, how to define g of x? In any value of x, the value is just 0. So that value is also 0. Therefore, the value of f dot g and g dot f are 0. So now we write the conclusion. Therefore, f dot g is equal to 0 and g dot f is equal to 0. F dot g and g dot f, both values are 0 for all values of x. So to find in both the cases, here modulus is involved. So first we find the value of the modulus. But in all the cases, f dot g and g dot f is not is equal to 0. So particularly some modulus is involved according to our given problem, the value is 0. Now we understand how to find the composition of two functions. Either it may be f dot g or g dot f. Now we move the next one. If f is a function from R to R, is defined by f of x is equal to 3x minus 5. Prove that f is a bijection and find its inverse. We already see the word bijection, but here now we introduce a new one. We say the given function is a bijection. Suppose the composition of two functions f and g, whose value is an identity, that is exactly will come the variable f dot g. Suppose to find both is a variable of x, whose final value is just x, or we say it is ix, or f and g is a function of y. So y, we say it is I, y, that is identity of y. Then we come to the conclusion these two functions are bijection and also is inverse to each other. So the working rule is easy. To find f dot g and g dot f, suppose the final answer is say variable x or y will come. Then we say these two functions are bijection and also one is the inverse of other. Now we are given only one function is given, the name of the function is f of x. Now we create another function and also we see the function is the inverse of that one. So what is the given function? F of x. How to define? 3x minus 5. Now I say it is y. F is a function of x, so I say it is just y. So the value of y is 3x minus 5. Now we create a function fully in terms of x. So y, the minus 5 becomes that side, plus 5 is equal to 3x. Y plus 5, suppose the multiplication 3 becomes that side, division is equal to x. That is the value of x is y plus 5 by 3. So now we write all of the values of x. Now we see x is a function of y, we say, because origin variable is just y. So how to write this x? Now I write this x is a function of y. So we write is g of y is equal to y plus 5 by 3. What is the reason to take y here? Origin is fully the variable is only variable is y. So we can't say it is g of x. So we say it is g of y. So now we have two functions. The functions names are f of x and g of y. Now to check both are in bijection and also inverse to each. So in this process, first I find the value of f dot g. How to write f dot g? F dot g of, what is the variable we include here? We see f is a function of x. F is a function of x. And g is a function of y. Here what is the second function? G. G is a function of y. So we say it is f dot g of y. How to write f of g of y? So f of, I write f of g of y. What is the value of g of y? Is a y plus 5 by 3. So it is a value of g of y. Now we write the value of f of x. For understanding, I write f of x. How to define f of x? Is 3x minus 5. So what is the nature of the function f? The bracket 1 variable is first of all multiplied with the 3. And it is separated by minus pi. So it is the working rule of the function f, or it is the nature of the function f. So the bracket 1 variable is multiplied with x, and also it is separated by minus pi. So we compare these two. In place of x here, y plus 5 by 3. What is the nature of the function f? First of all, the bracket 1 variable is multiplied with 3. What is the bracket variable here? Y plus 5 by 3. So the term is multiplied with the 3 and also is separated by minus 5. So we write it is 3 of, multiplied with 3, so 3 of, the bracket variable is y plus 5 by 3, and also it is separated by 5. So it is a value of f of x. We cancel this 3, y plus 5 minus 5. So f dot g, we see it is just a variable y. So it is a variable of the function g. So now we say it is f dot g is equal to iy. That is the identity function. Because we take except suppose a y will come a 2y or 3y, we can't say it is identity function. But we take exactly the variable y, so we say it is identity function. F is one function, g is another function. But we have identity. So what is the conclusion? One is the inverse of other. You know, in a lower class, we multiply two number. The resulting number is an identity number. We say one is the inverse of other. For example, I say 5 is a one number. Multiply with 1 by 5. What is the answer? 1. 1, you know very well, 1 is the always identity element in multiplication. So now we say 5 is the inverse of 1 by 5. Or in other words, 1 by 5 is the inverse of 5. So in the same concept apply here. We compose two functions, we are getting identity. So one is the inverse of other. Now we find f dot g. Also we find g dot f. Also to find g dot f. How to write g dot f? G dot f of x. Why I write x here? Because f is a function of x. Here what is the reason to write y? G is a function of y. Here f is a function of x. G of f of x. G of, okay, G of. How to define f of x? F of x is defined as 3x minus 5. F of x is defined as 3x minus 5. Now we have the value of g of this 3x minus 5. So g of y, how to define g of y? G of y we already take. G of y is y plus 5 by 3. So the bracketed variable is first of all added by 5. and the entire value is divided by 3. So in place of y, in our given sum is 3x minus 5. So that value is, first of all we write 3x minus 5. That term is added by 5. And the entire sum is divided by 3. So minus 5 plus 5 is cancelled. 3x by 3. So 3 is also cancelled. So g dot f, that value is x. That is g dot f is ix. So g dot f is also an identity. Therefore, f and g are bijection and inverse to each other. Both the function value is an identity. Therefore, we say the two concepts f and g is a bijection functions and also is an inverse to each other. That is, f function and g function is an inverse to each other. Now, our question to find the inverse also. So now g of y. What is the value of g of y? Is y plus 5 by 3. Now I say this g of y is the inverse of f. To write this g of y as f inverse of y also, y plus 5 by 3. How to write g of y as f inverse of y? We say these two are inverse to each other. So g of y is also inverse of f. So how to write inverse of f? We write f inverse. We write the inverse of x is x inverse. Inverse of y is y inverse. So the inverse of the function f, we write it is f inverse. F inverse of y. I replace y into x. So f inverse of x. Just y is we are putting y. Suppose we replace y by x, we write it is x plus 5 by 3. So this f inverse of x is the inverse of the given function. So now we finish the problem. The first rule is to find both the functions are, it may be inverse or bijection. Suppose the given function is a bijection, means it is inverse also. Next, we already say these two functions are inverse. So g of y is also, we say it is f inverse of y. We replace the variable y into x, we write f inverse of x. So this f inverse of x is exactly the inverse of f of x. Suppose we composition of this function, two functions, f of x and f inverse of x. The final answer is also will come just x. We say it is x, we say it is the identity function of x. Now we move the next one. The formula for converting from a Fahrenheit to a Celsius temperature is y is equal to 5x by 9 minus 160 by 9. Fahrenheit to Celsius temperature function is given. Our question is to find the inverse of these functions. To find the inverse and determine whether the inverse is also a function. So first of all we say the given function is a bijection or not. Suppose if it is a bijection, we come to the conclusion. It is also function is possible, the inverse is possible, the inverse is also a function. Given the value of y is 5x by 9 minus 160 by 9. I write it is a function of x. Y is a function of x. So I say it is f of x. 5x by 9 minus 160 by 9. Suppose we take this one. Two variable, that is f of x1 and f of x2 is not is equal. So it is also one of the concepts to find the function is bijection or not. So f of x1 is not is equal to f of x2. Now we will be taking, suppose this one is impossible, that is both are is equal is impossible. F of x, how to define it? 5x by 9 minus 160 by 9. So what is the value of f of x1? We replace x by x1. What is the value of f of x2? We replace x by x2. That is f of x1 value. Now I write f of x1 value. 5x1 by 9 minus 160 by 9 is not is equal to 5x2 by 9 minus 160 by 9. F of x1 is not is equal to f of x2. Now we see except this x1 and x2 all are the constant. Denominator same 9 minus 160 by 9. So this 1 is not is equal to means we come one conclusion x1 is also not is equal to x2. So these two functions is not is equal to means x1 is also is not is equal to x2. Suppose we replace the same value of x1 and x2, both are equal. Because except this x1 and x2 are remaining the constants, so x1 is also not is equal to x2. That is, if f of x1 is not is equal to f of x2, then x1 is not is equal to x2. So why we say this concept, sir? Suppose a function satisfies these concepts, then we say the given function is a bijection. So here also to prove the given function is a bijection. Suppose is not is equal, is exactly will come is equal, then we say the given function is not bijection. But if f of x1 is not is equal to f of x2, then x1 is also not is equal to x2, therefore f is a bijection function. So if it is a bijection function, the inverse is possible, and the inverse is also a function. So now we find the inverse. Our question is to find the inverse only. So what is the reason to find this one? That function is a bijection function, then inverse is possible, and the inverse is also a function. Y. How do you define y? 5x by 9 minus 160 by 9. It is a given function. Now to find the inverse of this function, that is we change the variable. Now here y is a function of x. Now we write in reverse. We write the x is a function of y. So that's why y is equal to, we see the 9 is common. So I write whole divided by 9. 5x minus 160. The denominator 9 becomes that side. It's a numerator. 9y is equal to 5x minus 160. The minus 160 becomes that side, plus 160 is equal to 5x. 9y plus 160 whole divided by 5 is equal to x. Okay, the multiplication 5 becomes that side, division. So we write this x as, okay, we write this x. We write in reverse. 5 is common, so 9y by 5 plus 160 by 5. What is the reason to split 5? Here there is a chance to simplify. So that's why I split the 5. So x is equal to 9y by 5 plus, okay, 32. 5 in 16, 3 times. Remainder 1, 10 in twice, 2 times. So x is equal to 9y by 5 plus 32. That is, I say it is f of y. Okay, is f of y, or is your choice will be take it is g of y also. Is your choice. I say it is f of y or g of y. 9y by 5 plus 32. Why I say it is g of y? It's another function. So g of y is the inverse of f of x actually. That is, f inverse of y is equal to 9y by 5 plus 32. Suppose we take it is g of y, f of y. Next also we say it is f inverse of y. Why we say it is the inverse of f, sir? Because f is a bijection function. We already proved f is a bijection function. Therefore, inverse is possible. we find the given function to convert the another one is a inverse. That is, we change the variable f inverse of x. We replace y by x. 9x by 5 plus 32. So it is the inverse of f of x. So f of x is a given function. And f inverse of x value is 9x by 5 plus 32. We already tell f is a bijation function, so whose inverse is also a function, and the value of the inverse is 9x by 5 plus 32. The same model problem lies in example also. We try. If you have any doubt, call us. We clarify your doubt.